Hello everyone. Write down rolling on an inclined plane. It's an inclined plane. This angle is theta, and this is an object which can roll. It can be a ring, disc, solid cylinder, hollow cylinder, sphere, solid hollow, anything which can roll. And therefore, these are the things which we always provide: mass, moment of inertia I, radius r. If it's a ring, we'll use I as mr square. If it is a disk, we'll be using I as mr square by 2. And similarly, you can use values for other objects. We have been given that this inclined plane is also rough and coefficient of friction is mu. Coefficient of friction between the wheel and the inclined plane is what? Mu. Now, if we draw the free body diagram of this object, then these are the forces acting on it. Downward force of mg, a normal reaction coming from the inclined plane, and normal reaction is always perpendicular, and therefore you can see it's going to act like this. This is the center of mass of the rolling object. Now, as it rolls down, look at this marker. If I release a marker on a rough inclined plane, as it rolls down, to start this rotational motion, you need to have some torque. Initially, you release the object without any rotation, and as it starts coming down, rotation starts. To start a rotation, you need to have what? Torque. What is the torque of mg and torque of normal reaction about an axis passing through the center of mass? This is the axis. Usual axis, if you have a wheel, you know that this will be the axis of rotation. An axis passing through the center of mass of the rotating body What will be the torque of mg and what will be the torque of normal reaction? Answer these two things first. Good. They both will have zero torque. Why? Because both these forces, normal reaction and mg, they are passing through the axis of rotation. And if a force passes from the axis of rotation, its torque is what? Zero. Which tells us what? What is that which is producing rotational motion? As you release it, initially there is no rotational motion present. The moment I release it, I hope you can see the rotation part. So as it rolls down the incline, what is that which is providing necessary torque? Who will answer this? Good. This is friction. Rotation is being developed with the help of what? Friction. So what is the direction of friction? Is it up or is it down? What do you think is the direction of friction? Is it up or down? If friction acts downwards, then about this axis its torque will be this. If friction acts like this, then its torque will be clockwise. If friction is downwards, then torque will be force like this, anti-clock. And for an upward frictional force, torque will be what? Clockwise. Now, I told you that mg and normal reaction, they cannot produce any rotation. Rotational motion, the circular motion part, is developed by the torque of friction. So when you release something like this, you know that it will come down with some velocity v, and it will have some angular velocity omega. That's what rolling is. Translatory motion and rotational motion. To start clockwise rotation, we need to have clockwise torque, and therefore direction of friction is up, is not down like this. So for this side up, direction of friction is this. This is your force of friction. So that you can produce what? Clockwise rotation. We'll see in other examples, but just remember this part. Some of you might think that body is coming down and therefore friction is acting up. But that's not how we decide direction of friction for any body, especially in the case of rolling, this rolling means motion of the contact point. And right now we are interested in pure rolling. And I hope you remember that during pure rolling, velocity of the contact point is zero. This thing is coming down, but contact point, its velocity is what? Zero. And friction opposes what? Relative motion of the contact point. So, if somebody is using the argument that wheel is coming down, then this argument is not correct. If you remember, it's something like this. If I start moving in the forward direction, when I started teaching you friction, I asked you in the very first lecture, I asked you this thing, that if I start moving in the forward direction, then what is the direction of friction? And almost everybody said that backwards, but that's not the correct thing. Since I'm moving in the forward direction, you cannot look at the motion of the upper part. It's the motion of shoes which will decide the direction of friction. Why? Because shoes are in contact with the ground. So this point is in contact with the ground. Pure rolling says that it's not moving, but friction opposes what? Tendency to move with respect to the contact surface. This point has a tendency, it is not moving, but it has a tendency to move downwards. To oppose that tendency, friction is acting up. So if we go and decide that tendency directly, it will become a bit complicated. In a very easy one line, we can decide the direction of friction with the help of sense of torque and sense of angular speed present in the rolling body. Note on this figure, these two side figures make a cross, and if you understand the way we have decided direction of friction and everything, then write down yes in the comment box. Now, what is that which is producing speed? Initially, when I release it, the body was at rest. The thing which produces rotation is what? Friction. Torque of friction is not zero. You can write like this, and later we'll calculate the torque of friction also. But this torque of friction is producing rotational motion. What is that force which is producing the V? The basic cause. Good. That force is what? Component of mg acting in this direction, which is mg sine theta. There are two components of mg. This is mg sine theta and this is mg cos theta. Mg cos theta is being balanced by normal reaction. We have done these things in laws of motion. Mg sine theta is responsible for V part. But this mg sine theta or this mg cos theta, they cannot start rotational motion. To start rotational motion, you need to have what? Friction. Which gives us a very interesting and easy to remember result. Let's see how many of you are going to answer this. If I release a disc or anything which can roll, if I release a rolling object on a smooth inclined plane, then when it arrives at the bottom, what will be present? Translatory motion, rotational motion, or rolling? Let me repeat my question again. In fact, write down the question. If an object is released on a smooth inclined plane, if an object is released on a smooth inclined plane, then as it comes down, what will be present? Rotational motion, translatory motion, or rolling? If you think it's translatory motion, then write down Tm. For rotational, Rm. For rolling, write down rolling. Only 4 responses so far, although the question is very easy. The moment I tell you smooth, friction becomes what? 0. If there is no friction, then this object will simply slide down. It will only have what? Translatory motion, like this. You're not going to observe rotational motion, because this omega is produced by the torque of friction. And for a smooth incline, this torque of friction is not present, and therefore as it slides down, you are only going to see what? V, which is because of mg sine theta. So write down the answer. As there is nothing present to produce torque, as there is nothing present to produce torque, there will be no rotational motion present in the body. There will be no rotational motion present in the body, and it will purely have translatory motion. And will purely have translatory motion. Now, for the given question, friction is present. Coefficient of friction is mu. And we have what? Pure rolling. Pure rolling means contact point is not slipping. If contact point is not slipping, then let's write down equations of motion. For any question in rotational motion, you know that we start with the help of F equals to ma. This is the first set. And the second thing is tau equals to I alpha. And the third thing is relationship between A and alpha. Acceleration of center of mass and angular acceleration of the body. So far we have solved all these questions with the help of these three things only. So how do you write F equals to ma? This wheel has a downward acceleration of A. This is velocity at a given time and उसी वक्त जो acceleration है body का, body मतलब center of mass का, that is A. It is rotating with angular speed omega, but it has an angular acceleration of alpha because of the torque of friction. So how many forces are present on the body? mg sin theta, mg cos theta, normal reaction, friction. लेकिन अपने को लॉज ऑफ मोशन से पता है भाई, क्या पता है अपने को कि अगर बॉडी along the incline जा रही है, this normal reaction is going to balance mg cos theta. इसलिए अपने ज्यादा काम का नहीं है बहुत ज्यादा काम का नहीं है. कितने काम का है बाद में देखेंगे. As far as acceleration is concerned, this normal reaction has no role to play. mg sin theta is being opposed by fr, and that's how you write F. What is F? mg sin theta minus fr. This is net force. Net force is equal to what? Mass into acceleration. Fr, mg sin theta minus fr is what? M into A. Look at this interesting thing. Fr is acting over here at the contact point. Mg sin theta is acting at the center of mass. But they are acting along this line. We have taken all these forces. This is acting at the center of mass. This is acting at the contact point. F is what? Total force acting on the body at any point whatsoever. We have found all those forces. But in the right hand side, A is the acceleration of what? Center of mass. So Fr is acting at the contact point, will not take acceleration of the contact point, which is 0 because of pure ruling. This A in F equals to ma is always what? Acceleration of center of mass, m into A. This is the first equation. Second will come from tau. Whose torque is present? Fr. What is the distance of Fr from the axis of rotation? R. So this is your axis of rotation and this is force. What is torque? Force multiplied by perpendicular distance. Fr multiplied by R. And is equal to what? I alpha. The last thing, if you have pure rolling, for any type of pure rolling, A is always equal to what? R alpha. What is A? Acceleration of the center of mass. What is alpha? Angular acceleration. From this, we can calculate Fr, and Fr is coming I divided by R. Let's save time. What is alpha? A divided by R. A divided by R. That's your Fr. Now add this and this. When you add these two, this term of FR is gone. FR cancelled. इसीलिए ध्यान रखना हमें इस R को अपने डिनोमिनेटर में शिफ्ट किया था, so that we can easily cancel this. Now when you add, on the left side you've got mg sine theta, and on the right side you've got what? ma plus this. We are adding this equation and this equation. On the right hand side you've got ma plus ma divided by ia divided by r square. ia divided by r square. Which gives us A as what? mg sine theta all divided by m plus I upon r square. This is acceleration during pure rolling on a rough inclined surface. An important result and those of you who understand everything, write down yes in the comment box, and if you are not comfortable with any part, write down no and also mention your confusion. But always remember these steps. You will get an equation from F equals to ma, which will take care of translate free part. Tau equals to I alpha will take care of rotational part. And this A equals to R alpha is coming because of pure rolling. Now, we have the acceleration mg sine theta upon m plus I upon r square. Coefficient of friction is mu. How much friction is acting on the body, on the rolling body? Answer this in the comment box. What is the force of friction acting on the body? Well, all the answers which I have got so far are not correct. मैंने जानबूझकर बोला था म्यू, जिससे कि हर आदमी आंसर दे कि एफ आर इज म्यू एन and therefore FR is mu mg cos theta. Who will tell me what is wrong in this? This thing is wrong. What is wrong? Who is going to tell me this? And this is something which we have done in friction only. This is something which we have done in friction. Good. That's the answer. But not in a complete sense, but still. Pure rolling. I'm giving you another 10 seconds. Who will answer what is the complete correct part? And take hint from this, especially from this. No response. Look here. FR is not mu mg. मैंने इस तरह से बताया फ्रिक्शन में. ज्यादातर लोग क्या करते हैं, एफ आर म्यू एम जी. फिर ज्यादातर लोग क्या करते हैं, एफ आर इज म्यू एन. जो करना चाहिए वो ये है, एफ आर मैक्सिमम इज म्यू एन. And when do we have FR maximum? When relative motion takes place between the body, that means between the contact point and the surface on which the body is trying to move. This wheel definitely is moving, but this contact point is not moving. Pure rolling means जो हमारा contact point है वो इस inclined plane के relative move नहीं कर रहा है. And friction opposes what? Friction opposes relative motion of the point which is in contact. Friction इस center of mass के motion को oppose नहीं करता. वो कहाँ जा रहा है, कहीं भी जाए. Friction किसको oppose करता है? Relative motion of this. Now, this point, contact point, is not moving, is not slipping, and therefore FR will be less than or equal to FR max, which we remember as what? Static friction is self-adjusting force. अपने नोट्स देखना, आपको याद आ जाएगा सबने किस तरह से चीजें कराई थी. हमने एक बॉडी ली थी, उस पर फ्रिक्शन काउंट किया था. मान लो मैक्सिमम फ्रिक्शन आया था 20. कुछ इस तरह का काम किया था भाई हमने. एक बॉडी थी, इस पर फोर्स हम लगा रहे थे 2, whatever be the data is, and suppose maximum friction is 20. If F is 2, the friction acting on the body, that was 2. When you increase the force to 3, this Fr also increase to 3, and so on. When this force becomes 20, Fr will also become 20. This is the critical point which was called ATM, about to move. So when you have ATM, about to move type of situation, then only Fr becomes what? Fr maximum. Then only Fr becomes Fr maximum, which is mu n, which in this case is mu mg cos theta, but not always. When pulling force is 2, friction is only 2. When pulling force is 3, friction is only 3. What is that? Static friction is self-adjusting. This is coming from friction. Hopefully you remember this part. Well, those of you who remember this type of thing, not exactly the same data, but if you remember the same thing, then write down yours in the comment box. And those of you who do not remember this, it's your duty. Go and see that lecture. So, your friction, and remember, write down everything like this. Fr is not mu mg, Fr is not mu n, Fr maximum is mu n. Friction which is acting on the body is less than or equal to Fr max, because this contact point, due to pure rolling, is not slipping against the inclined surface. Write down a point. Write down this point. Maximum friction acts when contact point is about to slip. Maximum friction acts when contact point is about to slip or is already slipping. Well, in detail, go and see that lecture of friction. If it's already slipping, then we use what? Kinetic friction. If they have given us mu s and mu k separately, if this contact point slips, we'll use mu k. We'll be using mu k into normal reaction. If they have only given us one value of mu, then that will be the mu static as well as mu kinetic. If this point is about to slip, is not slipping but is about to slip, friction will reach its maximum. If it slips also, then also Fr will be mu n. ये सारी चीजें हम कर चुके हैं, देख लेना इसको. Now, so Fr, when I asked you what's the value of Fr, and if you answer like this, then this is wrong. Because this is a specific value, a spatial fact, which is present only when slipping will take place or about to slip. Then how do you find Fr? सामने है IA upon R square. And what is A? This is A. That's the value of A. So what is friction acting on the body? Friction acting on the body is Fr I. I'll use a trick for the value of I. We'll write I as C into mR square. Let's write down I first and then we'll put the value of I in terms of C. I divided by R square multiplied by A, which is mg sin theta whole divided by m plus I upon r square. Now before I continue with Fr, let me teach you a small trick which we did in the lectures. In the lecture where I taught you rolling. The trick for acceleration. Before we continue with that friction part. How easy it is to remember this result. In laws of motion, when you have a body, remember, as a trick you need to remember this. How did you find acceleration of this? In laws of motion, when there was no friction and all. So how did you find acceleration of this? What is the force? mg sine theta. What is acceleration? Acceleration is force divided by mass. mg sine theta divided by mass. ये अपना acceleration हुआ करता था laws of motion में. And rolling, pulley type के जो questions थे वहां पर मैंने आपको as a trick क्या याद रखने को बोला? mg sin theta, as a trick remember, is producing acceleration in m and mass equivalent of the rotating body. That mass equivalent is what? I upon r square. Intentionally I am using different colors so that you can remember this I upon r square is coming because of the trick part. The actual derivation you already have seen. How do we arrive at this I upon r square? But to simply remember this acceleration. What is acceleration if you release the object on an incline in laws of motion? G sine theta. mg sine theta upon m. In rotational motion, what is the acceleration? Add I upon r square part also. So this I upon r square, remember as a trick. बाद में note कर लेना. Look here. So what is Fr coming? I upon r square multiplied by a. This Fr is now what? Less than or equal to Fr max. So we'll put the value of Fr in this, and when you put the value of Fr in this, you get this result. This is coming I CMR square. What is C? C is that coefficient which is present in front of mr square. For a ring, what is I? mr square. C is what? 1. For a disk, what is moment of inertia? mr square by 2. That means what is C? 1 by 2. For a hollow sphere, moment of inertia is what? 2 by 3 mr square. So what is C? 2 by 3. So every time you're using a rolling body, there is some constant or coefficient present in front of mr square. That is C. What is the advantage of using this? Look, this is CMR square divided by r square. Right here, this is what? mg sine theta whole divided by m plus c mr square divided by r square should be less than or equal to Fr max. What is Fr max? What is Fr max? Mu n. Mu n, which is mg cos theta. Normal reaction. Normal reaction is equal to what? Mg cos theta. कुछ स्पेशल नहीं है, आई को अपने CMR स्क्वायर पुट किया. Now the advantage is R square cancel, m cancel. ये जो इतना लंबा सा टर्म दिख रहा है आपको, ये फाइनली कुछ ऐसा बन जाएगा. It will look like this. Mu should be greater than or equal to C upon 1 plus C tan theta. Another result for rolling on incline. These are the two results. One is A, other is the second result is this mu should be greater than or equal to C upon 1 plus C tan theta. This is 1 plus C, this is C, everything else is gone. This part becomes this. It tells us what? If you need pure rolling, then coefficient of friction should be sufficient enough. How much? This much. It should be greater than or equal to C upon 1 plus C tan theta. अगर इससे कम होगा तो प्योर रोलिंग नहीं होगी. क्या होगी? बॉडी स्लिप करते हुए क्या आएगी? नीचे. रोटेट भी करेगी, आगे भी जाएगी, but it will not be a pure rolling. What is pure rolling? During pure rolling, contact point does not slip. If mu is less than this, then what will happen? Body is going to slip, contact point is going to slip. In that case, what will be the acceleration? देखेंगे अपन थोड़ी देर में. But as of now, note down this and put the whole thing inside a boundary and write down result. And when you write result, don't forget to mention that this thing and this, they are for pure rolling part. Note on this. One of you is asking, explain C part. What is there in it to explain? Moment of inertia of rolling bodies has this type of shape. If you have a ring or a hollow cylinder, they are basically same. If you have a hollow cylinder, you cut the slices, they become what? Ring. Then moment of inertia is mr square multiplied by 1. So we'll say that C is 1. If you have a disk, and we're talking about moment of inertia in the normal sense, when it's going to roll about this axis passing from the center of mass perpendicular to the plane. That's how it's going to roll. For a disk and solid cylinder, I was mr square multiplied by 1 by 2. So this mr square is always present. What is C? 1 by 2. We don't introduce this, we'll have to write I everywhere. But the I has terms of mr square which are easily getting cancelled. And therefore, just to remember the result in a very peaceful manner, we are introducing this simple concept of C. What is C? The coefficient which appears in front of mr square. Now, अब इस पूरे पार्ट को एक एग्जाम्पल की हेल्प से समझते हैं जरा. Look at this. This angle is 37. We have a ring. Its mass is 5 kg. Radius is 2 meters. Mu is 0.1. First, let's take mu as 0.5, and the second case mu is 0.1. They have given us two values of mu, 0.1, 0.1, 0.5 and 0.1 for two different inclines. Not like that one is static and the other kinetic. We have got two separate inclines. There are two questions, question number 1 and question number 2. The question is, in which case pure rolling is possible, 1 or 2? Or for none of these two cases? Or for both of these cases? Write down this in the comment box first. There are two inclines on which you place a ring of mass 5 kg, radius 2 meter. For which one pure rolling is possible? And those of you who can manage the second part, find out acceleration for both cases, 1 and 2. If you can decide pure rolling part, then you can answer the second part also. You need to answer accelerations also for both cases. Look, whenever they give you a question like this of rolling, you cannot use straight away A as mg sine theta upon this. You need to decide using mu whether body can roll in pure rolling mode or not. So for this question, mu for pure rolling mu should be greater than or equal to c upon 1 plus c. It's a ring. C is 1. Tan theta. What is tan 37? Tan 37 is 3 by 4. So mu should be greater than or equal to 3 by 8. Which is 0.3, 8, 3 24, 6, roughly 0.37. So mu should be greater than or equal to what? 0.37 for pure rolling, which is satisfied by this value of mu, but this doesn't. That means in case 1, it will be pure rolling, PR, pure rolling, because this 0.5 is greater than the 0.37 requirement. 0.1 is less than 0.37, and therefore in this case contact point is going to slip. When I write slip, it means contact point is going to slip. So for acceleration, in the first part you can write acceleration using this. You have the equation mg sine theta upon this. Well, this is something you can do it. M is given, g is known, sine theta is 3 by 5, sine 37. We'll make an easier version of this also, but as of now, mg sine theta divided by m plus I, it's a ring, mr square divided by r square. So you got your acceleration, whatever the value is, just find this. What I'm interested in is the second part. Once we have decided that for the second part slipping is going to take place, tell me what is the acceleration of the body in the second part. Let's see how many of you are going to answer the second part of the question. Look how easy it is to find acceleration in the second part, in the second case. Once I say that body contact point is slipping, once you say that contact point is slipping, I'm removing this, I hope you're comfortable with this part. Once I say that contact point is going to slip, friction becomes maximum. If it slips, it becomes what? Maximum. What is the maximum friction? Mu n. What is that? Mu mg cos theta. इस बार कुछ करना ही नहीं, इतना easy है second case में. What was this? This was mg sin theta. I need what? Acceleration. In just one line you can answer this. What is the acceleration? Net force divided by mass. So acceleration for this second type is simply mg sin theta minus mu mg cos theta whole divided by m. There is nothing, no term of I upon r square. You don't have to worry about that. What are the forces? This and this. What is the equation? F equals to ma. What is net force? mg sin theta minus fr. In the first part, we had no idea of fr and therefore we had to evaluate all the three equations. But this time round, we know the value of friction since this contact point is slipping. You cannot add that term of I upon r square. Remember, that was the trick for pure rolling. You can always use laws of motion, which tells you what? F equals to mass into acceleration. Whose acceleration? Acceleration of the center of mass. This is the acceleration when contact point slips. If they are giving you value of kinetic friction, then replace this mu with mu k. Procedure will be the same. If you are comfortable with this question, then write down yes in the comment box. Let's make this whole thing a bit interesting. And you can expect that type of concept in any examination, school or competitive examination. Let's see who answers this. There are two discs. This angle is theta and there are two discs, one larger and other smaller. So that its radius is r, its radius is 2r. And it is given that mu is sufficient for pure rolling. Then you need to find ratio of their accelerations. What is A1 upon A2? There are two discs, one is larger and the other one smaller, and they both are in pure rolling mode. So what is the ratio of their accelerations? I mean, they are also made of same material. Same material means, let's say they both are made of steel discs, same material, and therefore, based on their radius, you can find their masses also. Are you taking too long? Now, no answer so far. Well, just a little ago, I told you that we'll write this formula in a better way. So if you can all write the formula with the help of CMR square, everybody can answer this question. Replace I with CMR square and see that everybody can answer this question. Consider this a hint. We'll use this formula because we are interested in pure rolling. Replace I with CMR square, and then I hope everybody can answer this question in just 1 second. Remember, 1 second. Good. I told you 1 second. Answer is what? 1 is to 1. How come? Look here. What is A? M G sine theta divided by M plus I. What is I? CMR square divided by R square. M cancelled. R square cancelled. Your A is what? G sine theta divided by 1 plus C. Can you see? It's only this much. G sine theta upon 1 plus C. So this acceleration has nothing to do with size, mass, or type of the material. It can be steel, glass, steel, copper, anything, any size, as long as you have same type of rolling body, disc. A during pure rolling depends only on what? Type of rolling body. They both are disc, and therefore answer is what? 1:1. Itna easy hai. And write down this also as a result. During pure rolling, acceleration of the center of mass during pure rolling, acceleration of the center of mass depends on the type of rolling body. It is independent of the mass or size. It is independent of the mass or size. You can try this thing yourself. Take two different types of discs, two different types of coins. You can take a larger coin, you can take a smaller coin, place them on an incline such that they both can be in pure rolling mode. Adjust the angle so that they both are in the pure rolling mode. Contact point is not slipping. And you will find that they are coming down with same acceleration. If they are coming down with same acceleration, how will you know? They both will reach the ground provided you release them from the same position. If you release them from the same position, then they will both come down at this point after the same time. So it gives us the next question like this. We have an incline and everything is in pure rolling mode. And all that which can roll is placed on the incline at the same height. You have placed a ring, hollow cylinder, disc, solid sphere, solid cylinder, hollow sphere, solid sphere. Well, you cannot place a rod or a plate or a cube because these things are not going to roll. So anything which can roll, we have placed these things, and friction is sufficient so that every time it's pure rolling. And all these bodies are released from the same position. Don't have to worry about mass and R. The question is, arrange these bodies in the order of reaching bottom of the incline. Write down the question. Arrange all the bodies in the order of reaching bottom of the incline. The first one which arrives, then second one, third, fourth and fifth. Since it will be difficult for you to write this thing in the comment box, I want you to give me the first body to arrive and the last body to arrive. Write down these two. That will tell me whether you understand the question or not. What is the first body which will reach the bottom of the incline? And do it fast. Good. One of you has answered correctly. Look here. This is coming down with acceleration A. A is this. How do you decide time? S equals to ut plus half at square. हमने सारी की सारी bodies को एक ही जगह से release किया है. And therefore they all travel what? Same distance. Initially they were released and therefore u is 0. Let's save time fast. So your t is coming root over 2s upon a. That's your t. They are traveling same displacement. The one having larger A will take less time. Displacement is same. A ज़्यादा कर दो, T कम हो गया. The first to arrive means it will take less time. So if you want to have less time, you must have greater acceleration. To have greater acceleration, you have to decrease value of c. Look, question is done. सबसे पहले आना मतलब सबसे कम c. Let's see what's the value of c. For ring, it's 1. For disk, it's 1 by 2. What is 1 by 2? 0.5. For hollow sphere and solid, I hope you remember the trick. I'm removing the question part. For hollow and solid, the trick was solid is like S 2 by 5, which is 0.4. Hollow 2 by 3, which is roughly 0.6. So the question is, which one reaches first? सबसे कम C किसका है? 0.4. This is the first one. First one to arrive. First. Then what? 0.5. Second. Time wise मैं position बना दे रहा हूँ. This is first, this is second. Third is this. And last is this. Which means what? First arrives solid sphere, then disk and solid cylinder. In the third position you will have hollow sphere, and last to arrive are ring and hollow cylinder. An important result type question. सबसे पहले कौन आएगा? सबसे बाद में कौन आएगा? Experiment खुद कर लेना. Provided you are using this formula, which tells you what it should be pure rolling mode. Last 15 seconds. Suppose pure rolling is not possible for any of these bodies, then which one will reach first? Answer this part first. For no pure rolling, which one of these bodies, these rolling bodies, which one will reach first? Bottom of the incline. Should not take more than 3 seconds. Good. That's the answer. They all will take same time. And it's a good thing. The answer should be this fast only. They all will take what same time? Why? What is the acceleration when bodies slip? mg sine theta minus mu mg cos theta whole divided by m. There is no term of I. There is nothing like C. M is getting cancelled. M. इसका मतलब अगर स्लिपिंग होगी तो फिर सारी की सारी बॉडीज एक साथ कहां पहुंचेंगी? Bottom of the incline. Write down this last line. If friction is not sufficient, then all the bodies will reach bottom of the incline simultaneously. If you understand everything, then write down yes in the comment box. If you are not comfortable, then write down no and tell me your discomfort, and then you can leave. Thank you very much.